Hey guys, so here we have another exam paper. We've got the trial exam from 2025, Western Cape. This is a maths paper 2. If you want to download the paper, just check the description below. On 25 June, the points of the top 10 rugby sevens team on the rankings were as follows. First question, calculate the average. So to calculate average, we all know how to do that, right? We just go and add up all of these numbers, and then we will simply divide by how many numbers there are. So there's 1, 2, or there's 10 numbers. They did tell us that already. And so I'm just literally just going to go add them all up and divide by 10. And so you should get 64.9. 64.9. Okay, now this question says, determine the standard deviation. So to get standard deviation, you need to actually use your calculator for this, and you're going to use stat mode. So first step is just to press mode, and then put your calculator into stat mode, and then you're going to choose 1 minus VAR, and then you're going to go fill in all the values. So 27 equals 36 equals 50. So go fill in all the numbers. Once you filled in all the numbers, press the AC button, then press Shift, then press the number 1, and then you're going to have different options. We're looking for VAR, so you're going to press whatever that is on your calculator, and then standard deviation is this funny little thing that looks kind of like that. And so you're going to go press that, press equals, and you should get, I'm getting 23.86. Okay, now this question over here says, determine the number of teams whose points lie within one standard deviation of the mean. Okay, so the mean is 64.9. Okay, then all that you're going to do is you're just going to add one standard deviation of the mean to that. So if you add 23.68, you're going to get, let's put your calculator back into normal mode. So you're going to get 88.76 over here, 88.76. And then I want you to also take this number and subtract 23.86. So you're going to subtract 23.86. And that'll give you 41.04. Okay, so now all of the numbers that are within one standard deviation of the mean will be all of the numbers that are between here and here. So how many numbers do we have that are between there? So is the number 27 between there? No. Is the number 36? No. Is the number 50? Yes. This number is, 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 but then these ones are not, and these ones are not. So how many numbers are within one standard deviation? It's going to be 1, 2, 3, 4, 5, 6 numbers. So you're just going to say 6 numbers like that. If in an exam, I've never seen them do it, but they might, if they said within 2 standard deviations, then you would just take this number, which is your mean over here, and then you would add on 2 standard deviations. So you would add on, you would take this number, you would multiply it by 2, and then you would add it to this number. And then you would also take that number, multiply it by 2, and subtract it from this number. So that'll then give you these boundary numbers on the outside. Okay, but normally they just ask for 1 standard deviation. Okay, so let's just make sure we've done this, and let's move on to this next part. So it says that if all 12 teams' points, okay, wait, I thought there were 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, these are the top 10 rugby teams, but maybe there's 12 teams in total. So it says if all of the 12 teams' points are used. Okay, so this was just the top 10, guys, but maybe there's 12 teams in total. So if all 12 teams' totals are taken into account, the average is now going to be 59 per team. The data is represented in the box and whisker diagram below. Okay. Comment on the distribution of the data. Provide a reason for your answer. So normally when they're talking about commenting on the distribution, they're typically referring to like whether the data is skewed to the left, whether the data is skewed to the right. Okay, so let's quickly talk a little bit about this whole skew to the left and skew to the right. So let's imagine that we have, let's look at some data on the left. So I've written some numbers down here. So let's say we've got the numbers 3, 4, 7, 8, 10, 12, and 40. Okay. Now let's say on the, let's call this data set A and let's call this data set B. So for data set B, let's say we've got the numbers 5, and then we've got 31, 34, 36, 38, 39, 1, 2, 3, 4, 5, 6, and let's say we've also got the number 40. Now, if you had to quickly go and work out the median over here and the mean, can you go do that quickly for both of these data sets? Go get the median and go get the mean. So for the median, we know that it's the number in the middle after you've arranged everything from smallest to biggest. So that's going to be the number 8. Okay. And then for this data set here, the middle number is 36. Let's write that a bit better. 36. Now, if you had to go calculate the mean, remember that's just your average. So you go add all of the numbers together and divide by 7. And then you do the same over here. Then for this one, you're going to end up getting 12. And then for this one here, we'll end up getting around 31.9. Okay. Now, if you look at all of these values over here, okay, now if we had to just visually look at what these numbers look like, so if I had a ruler, and let's just say it goes from 0 up to 40, so the halfway would be 20, it's more like there, and then this would be 10, and this would be 30. Can you see that most of these numbers are in this area here? So that's where most of the numbers are, and then we've got one number over there. Then on this side, if we had to go 0 to 40 again, we've got most of the numbers now. Let's first just go say that this would be 20, this would be 30, and this would be 10. So most of the numbers now are in this area here, and then we've just got one little number over there. Okay, so when you've got most of your numbers on the left, and you've just got some one or two maybe little random things on the right-hand side, we call this skew to the right. Skew to the right. The word skew means that it's a little bit off. So we can see that everything is here, and then you've just got this one random thing that's just a little bit off to the right-hand side. So that's why we call that skew right. And then when you have everything on the right-hand side, and then you've just got one or two random numbers that are just a little bit off to the left, then we call this skew left. Okay? Now, when we have skew right and skew left, there's also some interesting relationship that happens with the median and the mean. So when we are skew to the right, then I want you to just quickly write the word mean on the right, and then put the word median on the left. Okay, and then when we have skew left, put the mean on the left, and then put the median on the right. So the mean must always go where we have the skewness. So if you're skewed to the right, then I want you to write the mean on the right-hand side. And if we are skewed to the left, I want you to write the mean on the left-hand side. So then if you had to then look on the number line, numbers that are further to the right-hand side are larger than numbers that are to the left-hand side. So this number is on the right and this number is on the left. So we will say that the mean is larger than the median. In the same way, here on this number line, numbers that are on the left are smaller and numbers that are on the right are larger. So now this means that the mean is now smaller than the median. Okay, and so a quick way, if we then go back to this question, to work out whether we are skew left or skew right is just to go look at the mean and then to go look at the median. So the mean is your average. They told us that that's 59. Your median on a box and whisker is this number in the middle, which is going to be over here. Now, if you look carefully, this is counting in fours. 64, 68, 72, 76, 80. So this is going to be the number 64. So the median is going to be 64. So can you see that the mean is 59 and the median is 64. So the mean is on the left, because on a number line, 59 is smaller than 64. So the mean always follows the skewness. So if the mean is on the left, then it means that this data is skewed to the left. Okay, and the reason for that, you can literally just say, is that the mean is smaller than the median. The term latitude refers to how far a location is from the equator. Latitudes in the northern range from 0 at the equator to 90 in the North Pole. Below are the latitudes of several cities in the northern hemisphere, along with the average maximum temperature for April in degrees Celsius. So for example, we've got Nigeria at a latitude of 6 degrees and a temperature of 32. So what they're pretty much saying, guys, like, this isn't geography, but you know that we've got a planet Earth, and right in the middle we've got the equator, and then we've got these lines of latitude that go like this. Boom, boom, boom. Okay, and then as an example, and then let's say this is our equator. Now, if you go 6 degrees north, then you're going to reach Nigeria. So maybe that's going to be like over here somewhere. So that's where Nigeria will be. And then if you go quite far, like 52 degrees up here, then you're going to get to London. Now, typically, the further you move away from the equator, the lower the temperature becomes. So what we can see in Nigeria, where it's at 6 degrees away, the latitude line is 6 degrees away, there's a temperature of 32 degrees Celsius. This degrees is not the temperature, that's just the degrees of how far away we are from the equator. And then if you go to, for example, Russia, which is very far from the equator, we can see the temperature is very low at like 8 degrees. And then places like London, also very far away from the equator, so they are much lower in temperature. So typically, the closer you are to the equator, the higher the temperature. Okay, that's the basics of what they're showing us here. Now for this question, it says, draw a scatter plot. Okay, now I don't have the answer book available, but all that I saw on the memo was that in the answer book, they gave temperature on the y-axis, temperature, and then on the x-axis we have latitude. Okay, so now it's pretty straightforward. I couldn't really see on the answer book whether they gave the different intervals, but we can pretty much see here that this goes all the way from, well, the highest value is about, let's say 60. I know it's 56, but let's just go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And then for the temperature, the highest temperature is 36. So let's go up in fours. So 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay, so if we had to go plot the points now, so this would be 6 and 32. So the latitude is around 6, so it's there. And then the temperature is at 32. So where those two intersect, you would put a little dot. Okay, now obviously I'm just using the dotted lines. Oh man, because I don't have a ruler. But, you know, with a ruler, I think it would be pretty straightforward. So let's just reconnect all of that. Okay. And then you get the idea, right? You're just going to go plot all of these. So we've plotted these two together. Now these two go together. So it's a latitude of 52, which is like here. And then the temperature is 13. So that is like there. And then obviously with a ruler, you would easily see where they intersect. Okay. And so now we're just going to go plot all of those points. Okay, so you're going to get something like that for your scatter plot. It's only worth 2 marks. This one says, determine the equation of the least squares regression line. So you're going to go take your calculator now and you're going to put it into stat mode. Okay, so let's go mode stat. Now we're going to choose a plus bx. And then you got x and y. So the first column they give you will be your x, and the second column is your y. And so you're just going to quickly go enter all of those values in the x column, and then all of those in the y column. Once you've entered all of that, just press AC, then press Shift, press the number 1. Now we're going to go for regression, REG. And now you can see there's different things that they can, you can get. You can get your A value, you can get your B value, you can get your R value, which is called the correlation coefficient. So I typically just tell learners, go get all three. So go get your A value, go get your B value, and then go get your correlation coefficient, which is R. I see that they are going to ask it anyways. So A is going, so you're going to press A and then you press equals, and that's going to be 40,27 if we round up. And then B, so to get B, you're going to press AC again, you're going to press Shift, you're going to press 1, you're going to press regression again, and then you're going to get B and you're going to press equals, and that's negative 0.51. And then you're going to repeat that whole process to get your R value, and you should get your R value as negative 0.91. Okay. So the equation of your least squares regression line, we know that the general equation is, let's write it over here, y equals to a plus bx. And so a we've just found as 40.27, and then b is a negative number, 0.51x. Okay, so we've done this question here. Now this one says, the city of Madrid, do they have Madrid over here? No, they don't. Okay, has a latitude of 40. Determine the estimated average temperature. Okay, so pretty much we can now take this equation. Just remember that x is your latitude, y is your temperature. So they've given us the latitude of 40, so we plug in 40 as an x value. So we can say that y equals to 40.27 minus 0.51, and then the x value is the temperature, or sorry, the x value. Now the x value is your latitude of 40 degrees, and so if you had to go work this out, you should end up with 19.87 degrees. So you can just write it like that. Now lastly, this question here says, calculate the correlation coefficient. So here we have it already, negative 0.91, and describe the correlation. So guys, I have made videos on this where I've tried to explain the different R values, okay? But let's quickly go through that. Now, you're going to see different things in different textbooks. I've seen so many different ways of describing it in different textbooks, but in general, all that you need to know is the following. If it's the number 1, we call that perfect positive correlation. Okay, I'm not going to write correlation the whole time. And then if it's -1, that's also extremely good. That's also perfect, but it's just a negative correlation. Okay, but 1 and -1 are absolutely perfect. What those would look like in a scatter plot is they would be, for the positive one, it would literally be a perfect straight line like that. And then for the negative one, it would just be a perfect straight line like that. So you can see there's a perfect relationship between your y variables and your x variables. So what that means is that there is a relationship between y and x. So you can see that it's not scattered randomly. It's a perfect straight line. Okay, so one would be when it's going up like that, when it's got a positive gradient. Okay, and then if your R value is -1, then it also is really good, but it just goes in a negative gradient. That's all. Okay, now if you get 0.9, or like somewhere around there, like 0.8, 0.85, 0.93, that is still very good. So we call that a strong. And because this one's positive, I'll just say strong positive. And then if it's negative, it's still very good. It's just got a negative gradient. So we'll just say strong negative correlation. Okay. If it's 0.5, we call that average or moderate. Okay, so I'm just going to use the word moderate. And then this would obviously be moderate negative And then if it's like 0.6, well, this is where some textbooks would still, they would give you like a range. They would say like anything between 0.5 and 0.8 as an example is moderate, and then anything below that. You know, different textbooks describe this differently. 0.2 is really not good, so we call that weak. So we call that weak positive. So what that would look like on a scatter diagram is you would have, where can I do this? Just remember that our R value is negative 0.91 for this question. But on a scatter diagram, if you have a weak relationship, it would be like this. Okay, it wouldn't be that bad. That would be more like 0. There would be a relationship, but it wouldn't look really good. It would be like something like that. So you can kind of see that it's going upwards, but it's not great. And then if it was a weak negative, well, then you would get something more like this. Weak negative would be more like something like that. So you can kind of see that it's going down, but it's kind of scattered all over the place. Okay, and yeah, so this would be weak negative. And then 0 would just be there's absolutely no relationship. So that would just be random. There wouldn't be anything that you can say. It would just be completely random. And so that would mean that, what that would mean in mathematics is that the latitude has no effect on the temperature. There's no relationship. Like, you can have places that are very cold on the equator and places that are very hot at the North Pole, and then you could have some places that are really cold at the North Pole and other places that are really hot at the equator, and there's just no relationship, there's no pattern, it's completely random. That is what an R value of 0 would tell us. Okay, and so yeah, you can just write that down if you want. So they ask us to calculate the correlation coefficient, which we did over here, and then they said describe the correlation. So we can definitely see that it's really strong. Like 0.9 is really good. What that looks like. I mean, we did go and draw our scatter plot earlier, but this guy over here went and erased it. But you know, negative 0.9 is really good. It's like that. You can see that there's a trend. It's not perfect, but it's following a pattern. So there is a relationship. So we will definitely say that it is strong, but it's negative. Negative is not a bad thing. It just means it's going like this and not upwards. That's all. So we'll say strong negative correlation. In the diagram, P, Q, R, and S are vertices of a parallelogram. Okay, so it's a parallelogram. So let's just remind ourselves that it's a parallelogram. And the x-intercept is that, QN, okay, that's all fine, and then they give us that angle. Right, so the first question is determine the gradient of QR. So the gradient of QR. Okay, so we know that gradient is equal to y2 take away y1 over x2 take away x1. So, you know, you could maybe call this point number 1, or you could call this point number 2. That's up to you. And so if we're to go work this out, we're going to get minus 2 take away minus 3 over 2 take away negative 5. And so just go type it on the calculator. We should get 1 over 7. So 1 over 7. This question here says calculate the size of this angle. So what we need to understand is that if you just had to extend this line, then what we have at this point M over here is we have a line going through like that. Okay? And this here is beta. But we know the gradient of this line. We know the gradient of this line. And remember that beta is also the same over here because of vertically opposite. So we've learned that if you have a horizontal and you have a line going through that, if you want to work out this angle, we call that the inclination angle. Okay, that is called your inclination angle. And there is a relationship on inclination angles. between the three things are gradient, inclination, angle, and tan. So we know that the tan of the angle gives you the gradient. And then if you have the gradient, then you can use reverse or shift tan of that gradient value, and it'll give you the angle. Okay? So remember that we already have the gradient. We've got the gradient of this whole line. This line here, we got it earlier as 1/7. So we have the gradient, so we can get the angle by just saying tan, shift tan of 1/7, and that'll give us 8.13 degrees. And it would have been nice, if they gave us different letters, like maybe I don't know, A over here, then we could have called this angle NMA, we could have called it like theta, and then we could have worked out theta first, and then said that, okay, so beta and theta are the same because of vertically opposite. But because it's only 3 marks on the memo, that is perfectly sufficient. And even if you just wrote the answer, they gave full marks for that question. Okay, so we got 8.13 degrees. 8.13 degrees. So this was 1/7. And then 8.13. Now it says determine the value of A. Where is A? A is over here. Very straightforward. We can go work out the equation of this line because we have all of the information of P and Q. And then once we have the equation of that line, we can just find its x-intercept. Okay, so we know that a straight line is y equals to mx plus c. And we know that to find m, that's the gradient, we use y2 minus y1 over x2 minus x1. So I will just use this as point number 2, this is point number 1. It's totally up to you. And so I'm going to say 2 minus 3, 0 minus 5, and that'll give us 1. And so now we have the gradient as 1, so we can fill that into this equation over here. And then to find c, for those of you that are very comfortable with equations and straight lines, you would know that the c value is going to be 2 because that's the y-intercept. But if you're not feeling comfortable with that, then to find c, you plug in any point on that line. So I will plug in this over here, but you could also plug in that one. And so you're going to get 2 as the y, x is 0, and so you end up with c equals to 2. So the final equation of this will be y equals to 1x. You can even just say x plus 2. Then to find the x-intercept, we make y0. And so we can say, let me just move me over here. And so we can say 0 equals to x plus 2. So if you had to go solve for x, you would end up with -2. So that means that this x value here is -2. So we can just fill that there. Okay, this next one. Determine the coordinates of S. Let me move me back down here, sorry. So it says determine the coordinates of S. So this you just do by inspection, guys. So if you look carefully at this parallelogram, we've got, let's more like there, and there. So what we have is we've got Q, okay? And we've got P. Now, and we've also got R. Now, if you just look at the coordinates, you can do this in different ways. You could look at how do you go from Q to P. Can you see how do the X values change? So I want you to just look at the X values only. Can you see that the X values go from -5 to 0? So can you see that the X values increased by 5? Then I want you to look at the Y values. They went from -3 to 2. So how much did they go up by? They also increased by 5. So when you go this way, the x's go up by 5 and the y's go up by 5. So if you wanted to, you could then take r and do the same. You would increase the x by 5 and you would increase the y by 5. Okay? And that would give you s's coordinate. You could also do it in this direction. You could rather go from Q to R. So you could see what happens when you go from Q to R. So you could see what happens to the X values. So the X values go from -5 to 2. So they go up by 7. And then the Y values go from -3 to -2. So they go up by 1. So then you can do that same thing from P to S. So you can do it in different directions, guys. It's going to get to the same answer. Okay, so I'm just going to do it in this original direction. So what we can see is that when you go in that direction, the X values go from -5 to 0. So the X values went up by 5. So if I increase this one by 5, I'm going to get a 7. And then this Y value went from -3 to 2. So it also went up by 5. So if I increase this by 5, I will get a 3. And then you just have to say inspection. And it's only worth 2 marks, guys. So please don't go do calculations. Don't go say, oh, yes, man, I can see that the gradient here is 1/7. So that means this gradient is 1/7. Yes, that is correct, but it's going to take you so long to do it that way because you've got 2 unknowns. And it's only for 2 marks, guys. Or, you might have said, yes, this gradient here is equal to 1. I must calculate it in the previous question. So that means this gradient here is also 1. Yes, you are correct, but once again, you're going to have 2 unknowns over here, and it's just going to end up getting quite complex, okay? One other way that you can do if you want that is pretty straightforward is you could say that you could work out the midpoint over here. You could work out the midpoint, okay? And then that is going to be the same midpoint for these two over here. That technique is also good. That doesn't take too long, but please don't go work with gradients and all of that. That's going to take a bit more time. Okay. Now, this question here says, so let's just also fill in here, 7 and 3. This question says, show that the diagonals bisect each other. Okay, so what that means is go find the midpoint of this one here, and then go find the midpoint of this one over here, and just show that you get the same value. So to work out midpoint of PR, we use the midpoint formula, which is x1 plus x2 over 2, and then you do the same for the y values. Do you know where this actually comes from? Like, what does it actually mean? Let me quickly show you. If I gave you one number as 70 and I gave you another number as 94, and I said, hey, I need you to help me find the number that is in the middle of those two. Well, there's a lot of ways that you could do it, but the easiest way is you just add them together and then you divide by 2. And that would be 82. Okay, for those of you that wanted to double check that. Yes, you can minus them, and then you can be like, oh yes, then I can make it half. And yes, there are other ways to do it, but it takes longer. So just add them together and divide by 2. And so that is exactly what we are doing with the midpoint. We're finding the middle of the x values, and then we're finding the middle of the y values. So for PR, okay, so I will just use this as my point number 2, and this is my point number 1. And so that's going to be 2 plus 0 over 2, and then minus 2 plus 2 over 2. And so if you had to go work out this one, you're going to end up getting 1. And if you had to go work out this one, you're going to end up getting 0. So the midpoint is at 1 and 0, which is like there. Okay. Okay. So if you had to connect them, your midpoint, this point over here, is at 1 and 0. Okay. Now, if you had to go and work out the midpoint of these two now, so now we're going to go work out the midpoint of QS. We're going to use x1. Okay, I'm going to run out of space. We're going to get, let's just write out the formula. And so I will just use this as 0.2, this as 0.1. And so I get minus 5 plus 7 over 2, and minus 3 plus 3 over 2. And so if you had to work this out, you end up with 1 and 0. So we get to the exact same answer. And then we can say, so what that means is that they're both going through the same midpoint. So this one goes there, and this one goes there. So because it's a midpoint, it means that this side is the same as this, and this length is the same as this. So what we can then see is that the diagonal lines are cutting each other in half. So this diagonal line is cutting this diagonal line in half, and this diagonal line is cutting this diagonal line in half. So the diagonals are bisecting. Bisect means to cut in half. So they are cutting in half each other. They are bisecting each other. So we can then say, therefore, diagonals bisect. And if you're Afrikaans, you can be like, "Hallo Jan, yes, die halflijner, die hoeklijner, what's it, hoeklijner? Die hoeklijner halveer me, bro." Okay. Okay, this question here says, show that the triangle PQR is isosceles. So PQR, so PQR is isosceles. Okay, so we know that a triangle that is isosceles has two sides that are the same, okay, like that. So don't waste time here. Look carefully at the triangle. I know it's not drawn according to scale, but most times they pretty much are. Which two sides look like they're the same length? Well, it's definitely this one and this one. So don't go waste time trying to find the length of that one. Go find the length of this one here. Go find the length of that one here, and just show that they are the same. Okay, so we'll go find the length of QP first. So we'll use the distance formula now, which is like the length formula, however you want to think about that. Okay, and so I'll use this as 0.2, I'll use this as 0.1, and so that's going to end up being minus 5 minus 0 plus minus 3 minus 2. And so if you had to work this out, just leave it as surd for now, 5 square root 2. And then if we had to go work out the length of QR, same formula. Okay, I'm going to just use this as 0.2, this is 0.1, and so QR would then be okay, minus 5 minus 2, move buddy, plus guys, you know this guy here, let me try to point at him. He needs to get a life. He follows me wherever I go. Like, I'm trying to work and then, oh, hello, move out the way, brother. He just follows me everywhere. And then minus 5 minus 2, what am I doing? Minus 3 minus 2. And then I'd go ahead, I'd type that all on the calculator. Like, you know when your mom tells you, can you please take your younger brother to the party? But he's like not that cool, but you kind of have to be respectful to your mom, and then you kind of have to walk around with your brother the whole time at the party. That's this guy. He's weird. Okay, come Kev. 7 squared plus 1 squared. And what do you know? 5 square root 2. And so we can see that these two lengths are the same, and so therefore we can say that triangle PQR is isosceles. This one, PSRQ. Okay, so it's the same one that we had earlier. PSRQ is a parallelogram. Yes, we knew about that already, thanks. But which other type of quadrilateral is it? Give a reason for your answer. Okay, well, it's definitely not a square because, you know, squares would have 90 degrees over there. It's not a rectangle because rectangles would have 90 degrees over there. So the only other shape really that it could be where it still has these slanted little angles is a rhombus. Now a rhombus, they have specific properties, one of which is that all of the sides are equal in length. So we've already gone and worked out now PQR. Remember we worked in this triangle here. We already worked out that these two lengths are the same. So that is enough. We don't need to go any further because of the fact that we already know it's a parallelogram, right? So because it's already a parallelogram, then that already means that the opposite sides are equal. So we already know that those are equal, okay? And it also means that these are equal. But we've just gone and shown that these are the same. And so you could just put one little line there, and then because this line and this line are the same, then it means that that's also just a one line. And so there we go, they actually are all the same. So we can just go say rhombus, and that is because we already had a parallelogram, so we can just say parallelogram, and then we found one pair of sides, adjacent sides. Adjacent means next to each other. So parallelogram with one pair of adjacent sides equal. Okay, now this song is, why this song? I got this stupid song in my head. It's actually not stupid, I flippin' love it, but I'm just maybe a bit embarrassed to say that I love it. But it's a song by Enrique Iglesias. Baby, I like it, the way you move on the floor. Oh yes, I like it. But then there's a certain part that's like, don't stop, baby, don't stop, baby. Yeah, I like that part. Whenever I play that, I just want to go have fun. Calculate the size of angle Q. Calculate the size of angle Q. Okay, so that's this angle over here. Right, mate. And that's only for 3 marks. Baby, I like it, the way you move on the floor. Oh, yes, I like it. Come on and give me some more. Okay. Honey, forever, fiesta, forever. Now, there's a number of ways that you could do this question. There's some longer ways. For example, one of the longer ways, but let's say you're in an exam and you're feeling stressed, you can do this. It's absolutely fine. You could make a triangle like this, right? And then you could, for example, what do they want? They want this angle. So you could go work out this length, you could go work out this length, and you could work out this length, and then you could use the cos rule in reverse. You know the cos rule, which is like a squared equals to, or no, c squared actually. You know, there's this equation over here, and you could work it backwards and find cos c. That's a long way to do it, but you can do it. So if you're in an exam and you're struggling, you can do it. You could even have made a triangle over here, and then you could just go work out this length, this length. Oh, we actually have those 2 lengths already. You're given, you genius, man. Because we already went and worked at both of those. Remember, 5 square root 2 or something like that. And then you could just go work out this one. And then you could use the cos rule in reverse over there. I actually might like doing that one, brother. Well, I'll be damned. I don't know if that's the one I want to do, though, because there is something we can do that might be a little bit faster. Nike even don't be boring, but let's just do that one. Okay, we'll do that one, guys. So we found out that PQR. Yeah, we already found out earlier that this was 5 square. Whoa, what was that? Square root 2. And then this length here is also 5 square root 2. Okay, but for those of you that maybe, I'm going to do that way. You're given. For those of you that we will do it, but there is a different way you could have done this. Remember that this is a parallelogram. So it means then that, can you see the F over here? So that means that this angle and this angle is the same. So then, because of corresponding, so then what you could do, we already know this angle, and you already know this line's gradient, or you could easily get it. That would allow you to get this angle because of inclination angles, and then you could work in this triangle here, and you could get this angle, which is that angle. That's what I was looking at first, but I actually think that this way I've showed now could actually work out better. And as I said, you can go there, or, oh no, let's not go there, let's go there. Because we know this length is 5 square root 2, and this length is 5 square root 2. So all that we need now is this length over here. So the length of PR, we'll use the distance formula. y2 minus y1 squared. Okay, I'll use this as point 1. I'll use this as point number 2. Okay, so 0 minus 2, and then 2 minus 2. Okay, no, that wasn't your phone vibrating. Your guy's phone shouldn't be on while you're studying. Well, unless if you don't have a laptop and you use your cell phone for studying, well, obviously you have to watch it right now. But if you do have a laptop, your phone should not be on next to you. It should be on airplane mode. And that's going to be 2 square root 5 as well. Ooh! Wait, oh no, that's 2 square root 5. These are 5 square root 2. The reason I got so excited, is that if this was 5 square root 2, then all 3 of these would have been the same, and then it actually would have been an equilateral triangle where all the angles would have been 60 degrees, and so we wouldn't have to go any further. But life didn't work out like that for us this time around. Okay, so we know then that this is 2 square root 5. Okay, so we can go write out our formula. C squared equals to A squared plus B squared minus 2AB cos C. Now remember, the way that this formula works is this part here is the angle, and then this side is the side opposite the angle. So the angle that we are looking for is over here. So the side opposite that is the 2 square root 5. So the 2 square root 5 is going to go there. So you're going to get 2 square root 5, and then all of that must be squared. And then these two sides are the other two. So it's this one and this one. Okay, so it's going to be 5 square root 2, 5 square root 2, and then minus, and then again 5 square root 2, 5 square root 2, and then cos of the angle, which is called Q. Right, now what learners do wrong, and I see this happen all the time, is that they think they can put all of that on the calculator. Guys, the cos Q is only with that part over there. So you cannot combine these numbers with it. So what you rather do is take these two numbers and take them to the left. Okay? And so if you take the number on that left, 2 square root 5, and you square that, and then you subtract both of these, then on the left side you should get, I love it when we get beautiful numbers, minus 80. And then you can type all of this on the calculator if you want. So it's going to give us negative 100. And then we have cos Q. So to get cos Q alone, we're going to divide by negative 100 on the left. And so you're going to end up with cos Q equals to, if you just type this on the calculator, it's going to actually simplify to 4 over 5. And then to get Q, to get the angle Q, you're going to say shift cos of 4 over 5, and that'll give us 36.87 degrees. In the diagram, a circle with a center O passes through the point A. The tangent to the circle at E cuts the x and y axis at C and B respectively, and then they tell us that that angle is that. First question, determine the equation of the circle. So we know that a circle equation is x minus a squared plus y minus b squared equals to r squared. And so your a and your b are your center of your circle. So this center is at 0 and 0. So you could just fill in 0 and 0. And that's actually just going to become x squared plus y squared equals to r squared. Now r is your radius. So you could just measure this length over here. So you just take out your ruler and measure how far it is from O to E. So I'm just going to get my ruler quickly. Don't be silly, guys. We don't use our ruler. You got to use the distance formula. Okay, so you're going to go OE. The length of OE is going to be x squared minus x1 squared plus y2 minus y1 squared. Okay, I'll just use this as my point 1. I'll use this as my point number 2. And so we should end up getting 4 take away 0 plus minus 1 take away 0 squared. And this should eventually give us, I think it's square root 17. Yeah, square root 17. Whoopsie, wrong button. Okay, now that is your radius. So if the radius, we can go fill that in here now as square root 17, and then that is squared. And so that's just going to become 17. And so your final answer will be x squared plus y squared equals to 17. Okay, so let's just remind ourselves x squared plus y squared equals to 17. This question, O is the midpoint of AE. Determine the coordinates of A. So what they're telling us is that if you have a line going through there, then O is the midpoint and A is the, it's the other point on the other side. So we can go use the midpoint formula. So we know that the midpoint formula of, so let's say we wanted to find the midpoint of AE, well, that goes x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Now, we already know the answer for the x midpoint. It's the midpoint is over here, so we already know the x value there, it's 0, and the y value is also 0. So we know that this answer, x1 plus x2 over 2, we already know that that should give us 0, and we already know the y midpoint, it's also 0. Okay, and so now we can just go solve this. So let's say that this is point number 1 and this is point number 2, and so we can go, we don't know what this is, so let's just call it x and y. And we'll say that this is our point number 1. So we can say x, because we don't know what it is, plus the x value of point number 2, which is a 4, over 2 equals to 0. And so if you had to eventually solve this, you would take the 2 over to that side, which would stay 0, because 0 multiplied by 2 is still 0. And so you'd end up with x plus 4 equals to 0. And then if you had to solve that, you would eventually get that x is negative 4. Now, using the same method for the y values, we would say y plus negative 1 over 2, and that should also be 0. And so if you eventually had to go and solve this, you should eventually find that y is 1. So the coordinates at A will be the x of minus 4 and a y of 1. So let's just fold that in here. Okay, this question here says, determine the equation of BC. So this is really easy because here we have a line and we know that it's a tangent. But first of all, let's just remember that it's a line. So we can say y equals to mx plus c. Now, we know that a tangent is always perpendicular to a radius. So if we have this radius, and we know that a tangent and a radius is always perpendicular. So if we can go work out the gradient of the radius, then we can easily get the gradient of the tangent, because when two lines are perpendicular, we can say that when you multiply their gradients, it should always add up to, which should always equal negative 1. That is just a property when two lines are perpendicular. When two lines are perpendicular. So let's go get the gradient of this line over here so long. So we can go work out the gradient of OE. And to do that, we use the gradient formula, which is y2 take away y1 over x2 take away x1. I'll use this as my point 1 and this is my point 2. You can do it the other way around. It really doesn't matter. And so if we had to go work out the gradient of OE, we should end up with, now remember the coordinates here are 0, 0. And so we can say minus 1 minus 0 over 4 take away 0. And this should eventually give us negative 1 over 4. So now we can go use this formula over here, and so we can say negative 1 over 4 multiplied by the gradient of BC, and it should equal to negative 1. Now to solve this, you can say negative 1 divided by negative 1 over 4, and the answer should be 4. So now we have the gradient of this line over here. Okay, so remember we were working with the straight line. So now we can fill in the gradient as 4. And then to find the c value, you need to plug any point on the line that we're looking for, which is this line here. So I don't know about you, but I can see that there's a point E over there. So you fill in the y as minus 1, you fill in the x as 4, and then you would eventually, after solving this, you should end up with a c value of negative 17. And so we can say y equals to 4x take away 17. This question says, determine the equation of the line which is through the center of the circle and it's parallel to the tangent. Okay, very straightforward. So it's through the center. Okay, so there's the center, and it's parallel to this line. So it's just going to do something like that, and it's going to do something like that. So we know that parallel lines have the same gradient. So we know that this is a straight line. It's y equals to mx plus c. So we know that its gradient is going to be the same as this one's gradient, which we already found was 4. Then to find c, some of you can probably already tell what c is, but if you didn't, then the rule is to find c, you plug in a point on the line. So the point you can plug in is 0, 0. And so you could go plug in 0 as y, 0 as x, and you should eventually find out that c is 0. And so the equation of that line will literally just be y equals to 4x. Next one, or the last one, the circle that has a center of A and B. Come on, why couldn't they just have left the question simple? Why did they always got to be, oh my goodness, 7 marks. Sorry guys, I'm out. You're on your own. Just joking. The circle with center S touches the circle with center O externally at E. Okay? BC is a tangent to both circles. Okay, so pretty much we've got like this other circle that kind of does something like that, where, whoops, let me just try to get this better. This line is going to be a tangent to both. Something like this. Oh my goodness. Sorry, guys. So something like that, right, where this line here is a tangent to both. Okay? So it says that the circle with center S, so let's just call this, this is the center S, let's just say S over here, and let's say that its center is A and B, touches the circle externally at E. Okay, so there's at E, fantastic, thank you. And it's a tangent to both. They say that the length of OS is 3 times the length of OE. So they're saying that this coordinate, or this length here, is, or let's rather say, they're saying that this length here is 3 times the length of that over there. Okay, so quite interesting, but not difficult. Actually quite easy. For 7 marks, what we can do is the following. We can literally just go and we already know that what this length is. We already know the length of OE. Remember we worked it out in this beginning question here. We already worked out that it was the square root of 17. So then we can say that the length of OS would be 3 times that. So it would be 3 square root 17. We can then go take that and put it into a distance formula. x2 minus x1 squared plus y2 minus y1 squared. So we know the distance already is 3 square root 17, and this can be our, because now we're looking at this length over here. So this could be our point number 1, this could be our point number 2. And so if we go fill that all in now, we could say A minus 0 and then B minus 0. Because remember these coordinates here are 0 and 0 squared. Now if we just go simplify that a little bit, we end up with square root of A squared plus B squared. Now what a lot of learners do wrong is they say, oh yes, bro, check here. So they think that if you just have the square root of that plus the square root of that, they think that it's just going to be that. Because they're like, yes, but look, the square root cancels the square. Not true at all. Because there's more than one term inside that square root, that is not true. If you just had a single term like that, then you could say yes. But you cannot say that. This is not true. Okay, so what do? Well, all we're going to do is we're just going to square both sides. So we're going to square both sides. Okay. And then that square will cancel whatever's, it will, this square here will distribute to each of the terms like that. Or it's one term, but it'll go to each of the parts. And so 3 squared will become 9. And the square root of 17 squared will just become 17. So that's what we have there. Then on the right-hand side, this square will cancel out the square root, and so you're just left with a squared plus b squared. So 9 times 17 is going to be, I think 149. I liked, oh no, 153. That was awkward. 153 equals to a squared plus b squared. Okay, so there we have one equation, but we have two unknowns. You guys didn't think it was going to be that easy for 7 marks, right? So all we do now is we go find another equation. So the other information that we know is we know this gradient. We know the gradient from there to there, but that'll also be the gradient from there to there because it's all on one line. So, if we know the gradient of this part, then we also have the gradient of that part. And so we can then say that the gradient of OS is the same as the gradient of OE, which was negative a quarter. Now we can just go make a formula using the gradient formula. So we know that the gradient of OS can be done with gradient formula. And so we could say negative a quarter equals to, now I'm just going to use the y value of point number 2 again, which is b. Take away the y value of point 1, which is 0, and then the x value of point number 2, which is a, and then 0. And you could have used this point as well. You could have said between these two. That's also okay. But I just like using this one because the zeros just make our mathematics simplify so nicely. And so you're just going to end up with b over a. Now, in mathematics, whenever we have a situation like this, I always tell learners to cross multiply. And so we can then cross multiply and we end up with minus a equals to 4b. And so I'm just going to get rid of the negative. And so we end up with a equals to negative 4b. Now, how beautiful is this? We've got two very simple looking equations, two unknowns. We know what to do from here, don't we? And so I'm just going to go plug this equation into here. And so we'll end up with 153 equals to, now I'm going to replace the a with minus 4b, and then it's squared, like we can see over there, plus b squared. Okay, now we're just going to go solve for b, so we could say 153 equals to 16b squared plus b squared. And so you're going to end up with 153 equals to 17b squared. So we can just say 153 equals to 17b squared. Divide both sides by 17. Oh, beautiful. So we got 9, and then b would be the square root of 9, which was plus and minus 3. Now, so we can see from this where b is, you can see that this is a negative y value. So we're not going to have the positive one. We're just going to have negative 3. And then you're going to go plug into here to get a. So a would then be negative 4 times b, which is negative 3. And so a would be 12. And so is that all that they wanted? Determine the coordinates of s. It's going to be a as 12 and b as negative 3. It is given that Q sin 61 is equal to P. Express the following in terms of P and Q. So immediately, we've done questions like this before, but normally they would say something like sin of 43 equals to K. We normally don't have a letter in the front, so the first thing I would do is get rid of that. So we would say sin 61 is going to be equal to P over Q. Okay, fantastic. Now, before we even go do these questions, let's go make our triangle. So we know that we're on the cast diagram. Now, some learners are like, Kev, I don't know where to draw the triangle. Well, for these questions, you get two types. You get sin 61 equals to P over Q, or you get sin K equals to 3 over 5, and K is bigger than 90. So in a situation like this, they're literally telling you where the quadrant is. 61 degrees. We know that that is in quadrant 1. But then in other scenarios, they won't give you the angle, but they'll give you all of this information. So in one like this, they're telling you that sin of whatever the angle is a positive number. So that would mean you could be here or here, because that is where sin is positive. And then they give you one extra piece of information saying that the angle is greater than 90. So that would have to be over here. And then you would go draw your triangle over there. But in this question, they literally said 61 degrees. that is quadrant 1, because remember we start here at 90, at 0, then we go to 90, then we go to 180, then we go to 270, and then we go to 360. So any 61 is going to be somewhere inside here. Okay, so that's that. So let's just draw our triangle now. And then we'll always put the 61 over there. I always tell learners, just go fill in this angle. So we know that this is 90. So then if you had to go work this out, you should eventually find that this one is going to be 29 degrees. And they say that sin 61 is P over Q. So we know that from SOHCAHTOA, we know that sin is opposite over hypotenuse. So the opposite of this would be there. So that would be the P. And then the hypotenuse is there. So that would be the Q. And then you would use Pythagoras to find this side over here. So you could say Q squared is equal to P squared plus the unknown squared. So let's just call it X. And then if you had to go solve for X, you would get Q squared minus P squared, and then square root of that. So now we have the triangle complete, and now we easily go answer all of these questions. First question, cos 151. So we take the 151 and we need to reduce that. So remember that on the cos diagram, this is always the 180 minus x, this is 180 plus x, and this is 360 minus x. So where would 151 be? Well, that would be, and remember that this is 0 degrees, this is 90, this is 180, 270, and 360. So where would 151 degrees be? Well, that would be here. So the rule is you then need to rewrite it like this. So you're going to rewrite this as cos 180 minus. Now don't put 151 here. You need to put a number here so that this is still 151. So you're going to put the number 29. And because now, can we agree that that is 151, but this is also 151? And so we haven't really changed the question, we've just written it a little bit differently. Now we know that whenever you have cos of something in this quadrant, like cos 180 minus x, then it always becomes a negative answer, and then you just write the angle. So it'll become the negative of cos 29. And so now we can just say negative, and then we can go get cos 29 from our from our triangle. And we know from SOHCAHTOA that cos is adjacent over hypotenuse. So from this angle here, the adjacent is P and the hypotenuse is Q. And so we can say negative P over Q. This one says, what is the sin of 122? So once again, we just write out sin of 122. Then we need to see where is the angle 122. Well, it would also be somewhere over here. So we then go rewrite it as 180 minus. Now 180 minus what gives us 122? Well, I'm just going to say 180 minus 122, and that'll be 58. There we go. Now that then just becomes the positive of sin 58. Because we know that sin is positive in this quadrant. This is all just reduction. Okay, now 58, we don't have 58 in our diagram, but often you need to look at the following. You need to try either use the angles of 30, 45, and 60 together with one of these. So for example, if they gave you the sin of 16, then you could say that that is the same as 61 minus 45, and then you would have a 61 over there, and you would have a 45, which is a special angle, and then you could go use your grade 12 compound angles and expand, and then you would have 61s, which we have, and 45s, which are special triangles. So, or special angles. Ooh, I've just erased everything. Okay, so what did this say? This would have said 90, and then this would have been a line going down here. But that's not the scenario here, so there's no way we can use a special angle here. But then you also need to look at doubling and halving. So we can see that this number is double that number. So then what we can do is realize that here we have a double angle. So let's go get our double angle formulas on our formula sheet. And so specifically we'll look for the one with sin, which is this one over here. So it says that this is where the double angle goes. So we'll change, so if we have sin of 2 times 29, then you see how the 2's there. And so all that you need to understand is that this just becomes 2 sin 29 cos 29. So let's just write it here, 2 sin 29 cos 29. Now we've got 29s on our diagram, so everything looks good. Now the sin of 29 is going to be, so you start over here and then you use opposite over hypotenuse. So the opposite is going to be there, so you're going to have square root of q squared minus p squared over the hypotenuse, which is q. And then we need to multiply all of that with the cos of 29, which I think we did get that over here because this became negative cos 29. Oh, but now it's just positive cos 29, so it's going to be positive p over q. Yeah. Okay, and there's not much we need to do there, so we can kind of leave the answer like that. Now, there's not much that needs to be changed. All that we really can do is just multiply these two together at the bottom. And so we're just going to end up with 2p. I'm just putting that 2 and that p together. And then we've got the square root of q squared minus p squared. And then at the bottom, we've just got q squared. Now this last one, so we've done this one, cos 31. So remember, it's always going to be either you're going to have to use doubling or halving, or it's going to be some type of special angle type of thing. So can you see that here's 61, so we can rewrite cos 31 as 61 minus 30, because that gives us 31. Now we know that 61 is on our diagram, so that's good, and 30 is a special angle, so we understand that one. So we can go and expand this now using our compound angles. And so we're looking for the one that has cos of something minus something else. So cos of something minus something else, so that would be this one here. And so now we're just going to go and expand it using this. So it's going to become cos 61 cos 30 plus sin 61 sin 30. Now cos 61, if you just get cos 61 from the diagram, it's going to be adjacent over hypotenuse. That's going to be square root q squared minus p squared all over q. And then cos 30, just type it in on your calculator, square root 3 over 2. Sin 61, we already knew it from here, but you could also just get it from the diagram. It's just going to be p over q. And then sin 30, type on your calculator, it's a half. Now we can obviously just try put this, we can simplify a little bit. So I'm just going to leave that as square root 3 q squared minus p squared. And then that's all going to be over 2q minus, this will just become top times top, which is p, and then this will just be 2q. And then it's like when you have fractions, for example, if you have 3 over 4 take away 1 or 2 over 4, or let's say 1 over 4, then we know that when the denominators are the same, you can simply combine them like that. And so here we've got denominators that are the same, and so we can write it all over 2q. And then we can just put all of this together. Q squared minus p squared minus p. Now, we know that when you multiply two things that are in a square root, like the square root of a times the square root of b, it's the same as just multiplying them together. And so what you'll see on the memo is that they decided to put these two together. So it just became 3, and then in brackets they had q squared minus p squared, and then all of that in that square root, and then minus p. And you could also multiply the 3 into that bracket if you wanted to, and then at the bottom you're just going to be left with 2q. So here we have a nice little 6 marker, so let's go and fill this all in. So sin of negative x, let's talk about that, because a lot of learners, they'll say, yeah, Kev, it just becomes negative sin x. It does, but be careful, because so many learners, they just like, yo, I'll take the negative out as a common factor. It gives you the correct answer, but it's not the right way of thinking about it, because if I then gave you cos negative x, if you then take the negative out and put it in the front, that is completely incorrect. So the correct way to actually think about this is the following. We know that we've got something called a cast diagram, and our goal is to try turn all of these things into something that is on here. So at the moment, sin of negative x we don't find that anywhere over here. So what we do is we add 360. You are allowed to add or minus 360 as many times as you want when you are on these diagrams. The mathematical reason is the following. If you are here and you add 360, you will still be there. And if you subtract 360, you will still be there. Even if you subtract 360 again, you will still be there. So mathematically, you are allowed to add or subtract 360. Now, the reason I did that is because now, notice how these are being plussed, so the order doesn't matter. So I can just write it like this instead. And so have a look carefully, we now have that. And we know that sin is negative in that quadrant, so this just becomes negative sin x. So if this was a tan, it would work exactly the same. But if it's a cos, then at the end you would end up with cos 360 minus x, which is actually a positive for cos. And so it would be positive cos x. Okay, so this is just going to change to negative sin x. This one here is really easy because it's already on the cast diagram, and we know that sin is positive in that quadrant. Remember, it goes C, A, S, T. So that's where they're all positive here. Sin is positive here, tan is positive here, and cos is positive here. So this just becomes sin x. Then it says plus. Now when you have 90s involved, that is actually your co-functions. We have 4 of them, so let's go write them down. Okay, and let's get rid of this. Right, so this one here just becomes cos. This one here just becomes sin. This one here becomes cos. And then this one here becomes negative sin. So this one, of course they gave us the difficult one. So we make that a negative sin x. Then at the bottom, this negative just chills by itself. And then you've got a sin 360 minus x. So we know that that is where sin is negative. So it becomes negative sin x. And then minus tan of 315. So tan of 315, where is 315? Well, remember, we start at 0 degrees, then we go to 90, then we go to 180, then we go to 270, and then we go to 360. So 315 degrees is somewhere in this quadrant here. So what we then do is we rewrite it as 360 minus 45, because then this still gives us 315. Then we know that tan is negative in this quadrant, so it becomes negative tan 45. So let's say here negative tan 45. Now we can just go simplify, so this part here will become sin squared x. Okay, and then this becomes negative. Then at the bottom, this is a positive. This is a positive. And tan 45, if you type it on your calculator, it actually just becomes a 1. So what I'm going to do now is at the top, I can take out a negative sin as a common factor. And then you're just left with sin x plus 1. And at the bottom, we have sin x plus 1. And so these cancel. And so you're left with a final answer of negative sin x. And by the way, you don't get marks for all of these parts that I showed you on the side here. They literally are happy for you to go straight from here to here, and from here to here, and from here to there. You just get marks for that, and then from there to there. You don't need to show all the steps that I showed you. I was just showing you how you break that all down. Given the following expression, prove that it is that. Okay, so we need to do a identity. I'm going to start on the left side. It just looks a bit more easier to work with. So the left-hand side is cos A plus 45. Now immediately I see that this is going to be compound angles. And so we will look for the one that has a cos of something plus something, which is over here, and we will just go and expand it. So it'll become cos A cos 45 minus sine A sine 45. Now, cos A stays like that. Cos 45, put that on your calculator, it's square root 2 over 2. Sin 45 is also square root 2 over 2. Now, we now have a, let's just see how we can write this a little bit better. Okay, so we now have a common denominator, because you can think of this as 2 square root 2 cos A, which is that part there, I just switched the order, over 2 minus square root 2 sin A over 2. Now, that will just be square root 2 cos A minus square root 2 sine A over 2. Now, the only way that they've got it like this is because they didn't use the calculator. So all we do now is you take out a square root 2 as a common factor. And then at the bottom you've got that. Type this on your calculator then, and what you'll see is that it's going to give you 1 over square root 2. So we can rewrite this as 1 over square root 2. So at the bottom you're going to have a square root 2, and then at the top you're just going to have a 1, but that doesn't do anything, so we can just leave it then as cos A minus sine A, and that's exactly that. And then we can say, therefore, whoopsie, left-hand side equals to right-hand side. This question now says, hence or otherwise solve for A if they give us this expression. Okay, so let's go write that out. Cos A minus sine A equals to 1 over square root 2. So when they say hence, you kind of have to use the previous information as well. So here I see a cos A minus sine A. Let's just get that by itself. So if you have cos A plus 45 equals to cos A minus sine A, and that's all over square root 2, we can multiply this across. So we would end up with square root 2 cos A plus 45 equals to cos A minus sine A. So now we can see that cos A minus sine A is equal to that, but cos A minus sine A is also equal to that. So then what we'll do is we'll just say that these two expressions must then be equal to each other. So we can say, therefore, square root 2 cos A plus 45 must be the same as 1 over square root 2. And now it becomes a lot easier to work with, because now we can get cos A plus 45 alone by simply dividing by square root 2. So you're going to say 1 over square root 2 divided by square root 2. And so cos A plus 45 is going to end up becoming a half. And now you can literally forget about the rest of this entire question, and this just becomes a whole brand new general solution type of question. So first step, get your reference angle, so that you're going to say shift cos of a half. So your reference angle is going to be shift cos of a half, and so your reference angle is going to be 60 degrees. Then in quadrant 1, you're going to say quadrant 1, we're going to say that A plus 45 equals to the reference angle plus K times 360. K is an element of Z. And so if you had to solve this, you would eventually get 15 plus K times 360. K is an element of Z. Then cos is also positive in quadrant 4. So we would then say A plus 45 is equal to 360 minus the reference angle plus K 360. K is an element of Z. Okay, and if you eventually had to go and solve this, you should eventually get 255 plus K 360. k is an element of z. Now they want us to get a specific answer between 0 and 90. So this is where you will now go and plug in random values for k and see what answers you get. If you go through that whole thing of plugging in different values of k, you're actually only going to get one answer, and it's just going to be 15 degrees over here. Everything else is going to land up outside of that interval over there. Determine the general solution of that, and that is for 6 marks. Okay, but it's going to be super straightforward, guys. Check this out. Does this part here look familiar? Well, that is a double angle right there. And so can you see that we've got 2 sin x cos x? So we've got that. So we can just rewrite it as that. So we can rewrite this as sin 2x. And then we take the 0.8 over, so it becomes positive. And now we just go do a basic general solution type of question. Like this we literally learned like grade 10. The basics of this already, and then grade 11 we took it a bit further. And so, you know, step 1, get your reference angle. So reference angle, you're just going to say shift sin of 0.8. Don't round this part off. So this will give us, make sure your calculator's in degree mode and not radian mode, please. So let's keep 4 decimals, so 1301. Okay, now we go to the quadrants. So it's saying that sin is positive. So we know that sin is positive in quadrants 2 and 1. Okay. Remember that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And it's the A, S, T, C. So sin is positive in quadrants 1 and quadrants 2. So in quadrant 1, we'll say 2x equals to your reference angle plus k times 360. Some teachers use n, it's okay. K is an element of z. If we had to go solve this, you would just divide everything by 2. So that'll be 26.57. And yes, that also includes this part that you divide by 2. Learners always ask that. Okay, so there's that answer. And then the next quadrant is quadrant 2, so you start over again, but now you say 180 minus the reference angle plus k 360, k element z. And so if you had to work that part out, you're going to say 180 minus 53.1301, and that'll be 126. Let's not round off because it's not our final answer yet. 8699. Plus k 360, k element z. Then we can go divide everything by 2 now. Now we can round off, so 63.43 plus k 180, k element z. This one looks interesting. So it says that prove that that ugly looking expression is non-real for any real value of m. Now personally, I don't even know what that question means, but we just start and let's see where it goes. So the first thing I immediately see is that part there, forget about the square, just that cos, whoa, where are we writing, Kev? Just that cos 90 minus m. That is a cofunction, which you should know that there are 4 different cofunctions, right? And that one there becomes sin m. So if we then just have a square, then it just becomes sin squared m. So that's where I would start. So I would say the negative is just chilling in the front. That's got nothing to do with it. So I would go and write this as sin squared of m. And then this is just negative cos m. Now what does cos of negative m become? You can think of it as cos negative x. Well, it's not negative cos x. What happens is that if we have a cast diagram, we know that this is 180 minus x, this is 180 plus x, and this is the 360 minus x quadrant. Now, I've always told you guys, if something that you have is not on this diagram, then you can always add or subtract 360. So I'm going to add 360 to this. Why are we allowed to do that once again? Because if you are here as an example, and then you subtract 360, you're going to be back at the same place. If you add 360, you will still be back at the same place. So mathematically, you haven't changed where you are. So the reason I did that now is because now I can see that these are being added. So I'm allowed to change the order. And so I get 360 minus x, which is here. And I know that cos is positive there. So that just becomes positive cos x. So this part here is going to be positive cos m, like that. Okay, and so now what we have so far is negative sin squared m, and then this part here will become minus cos squared m. Now I'm seeing something from grade 11. I know that from grade 11, if you have sin squared x plus cos squared x, I know that that's always equal to 1. So if I then take out a negative as a common factor here, then I end up with sin squared m plus cos squared m. And so this just ends up giving us negative 1. Now we know that if you go type in the square root of negative 1 on your calculator, you're going to get an error. And so they said, prove that this expression is going to be non-real, which means you get an error on your calculator for any value of m. And so we can say, therefore, non-real. So let's just say here, non-real. In the diagram, the functions of f and g are given for between minus 120 and 20. So you can see we are between minus 120 and 20, and they've given us two equations. They've given us a cos graph and then a sin graph. So the sin graph is going to be, because this one you can see has shifted. So find the graph that hasn't shifted, and that would be this one here. Okay, so that is our sin graph. And then the other one would be the cos graph. Yo. But I was using jumbo highlighters, my bro. Yo. Given. My word. Come on. Okay. So the first question says, write down the period of G. So G is the yellow one, and a period means how long does it take to make one complete cycle. So remember, a complete cycle is up and a down. Okay, so a complete cycle, you could, for example, go from here to here, or you could go from here to here. It doesn't matter. But what you'll notice is that it's completing one whole cycle in 120 degrees. So you'll say 120 degrees. Now, the next question says, what is the value of A? So we can see A is over there. So remember that in a trig equation, you could get, we usually get something like this. Now, they've made it a little bit weird by the fact that they've put the A there instead of there. But that's okay. But let me just remind you what each of these expressions does. So this part here, that is like your vertical stretch. So if, for example, you have that, and this is a 1, and this is a minus 1, then A would just be 1. But if they then stretch all the way like that, and they go up to like 3 over here and minus 3, then A would be 3. Okay, so that part there takes care of your stretch. This part here is your vertical stretch. Okay, then this part here tells you if the graph has been moved up or down. So that's up or down. This part here tells you whether we've gone left or right. And then this part here tells us whether we have been stretched in the horizontal direction. So the way that we tell that is a normal sin graph would normally complete its cycle in 360. That is the normal period of a normal sin or a cos graph. But this graph here is completing in 120. So it's definitely been compressed. Okay? So it's been compressed by a factor of 3, because it's normally a 360 degree, but now it's finishing in 120. So it's been compressed by a factor of 3, and so that affects this value here, which is the A that they're talking about over there. And so we are going to say 3. This question over here says, write down the range of f if it is subtracted by 1. So let's just go look at the normal graph of f for now, and let's go look at its highest and lowest point. So f, I don't know why I erased all of that, is the green graph, okay? So the green graph at the moment has a maximum y value at 1. So you can see it's got a maximum y value of 1, and it's got a minimum y value at -1. So that is the current highest and lowest point of that graph. But then they subtract it by 1. So if you subtract this by 1, it's going to become -2. And if you subtract this by 1, it's going to become a 0. And so now all of a sudden, we can say that the new range would be y as an element going from -2 up to 0. If you prefer set builder, you could say y is bigger than or equal to -2, smaller than or equal to 0. And that is the answer for 6.3. Okay, this next one says, if h is obtained by shifting the graph of f, which is the green one, 30 degrees to the right, okay, so they're going to take this current graph and shift it 30 degrees to the right, and then they reflect it in the x-axis, write down the equation. Okay, so let's do it one step at a time. So the current graph of f is cos x minus 60. Now, if you move that graph another 30 degrees to the right, then whenever you move right, you put a minus, right? Remember, whenever we go right, x becomes negative. Whenever we move left, x is positive. Okay, so that's going to become cos of x minus 90. Okay, now we then take that and we reflect it in the x-axis. So whenever, here's the x-axis, and whenever you reflect something in the x-axis, the y value flips. So if you, for example, had a point over here at 30 and, or let's say we had a point up here at 30 and 1, when you flip it in the x-axis, it'll go to 30 and -1. So all of the y values will become the negative. So if we have this at the moment, and then we put a negative in front of the y's, and then we get y alone again, then that negative is going to end up going there. Okay, so this is what we now have. Now, we need to try simplify this in its most simplified form, as they say over here. So we don't really know x minus 90. We know 90 minus x, because then we can use co-functions. So what we do is we take out a negative inside that bracket, and so it'll become 90 minus x, like that. Okay, let's put a square bracket here. That negative is not allowed to jump outside. It doesn't work like that with trigonometric functions. So let me just write over here what we have again. So we've got negative cos negative 90 minus x. And let's keep that in a square bracket. Now, I want you to remind yourself what happens whenever you have a cos of, let's say, negative w. Let's say you had some equation, cos of negative w. Can you remember what that becomes? It doesn't become negative cos w. Remember that if you have a cast diagram, or let's use w instead for this example, then what I've always told you guys is that if this doesn't look like anything on this diagram, then you can add or subtract 360. And if we then take this and we add 360, let me do it somewhere else. So I'm going to write it down here at the bottom. So if we then add 360, so cos, let's write that nicely, cos minus w plus 360. Because we're plussing, the order doesn't matter, so this can be rewritten as 360 minus w. And I know then that that is on my cast diagram, and I know that cos is positive there, so that just becomes cos of w. So then what I can remember is that cos of negative anything just becomes the cos of that thing. So if I then have the cos, over here I've got negative cos of a negative of something, then remember what we've just learned is that that is just going to become the cos of that something. So that's going to be 90 minus x. So the w is the 90 minus x, okay? And then I know that cos 90 minus x is a co-function, which just becomes sin x. And so there, but now they wanted us to call that h. So h of x will be negative sin x. Okay, and now this last question, well, let's just write out the answer that we got here. So we said h of x was negative sin x. Okay, this one, for which values of x? Okay, so it's one of these questions where if you've watched any of my videos before on this, where, you know, what we do is we use like a table method here. So they want you to multiply that part and this part, and they want the answer to be greater than 0. So they want the answer to be a positive. So in mathematics, you can even think all the way back to like grade 5. If you multiply two numbers together, how do you make a positive? Well, you either want them both to be positive, or they can both be negative, because if you multiply two negatives, that'll also give you a positive. So this will be scenario 1 that we will go and look at, and this will be scenario 2 that we will go and look at, okay? So, and we're only looking at the graph of f. So let's go look at the scenario 1 first, and specifically, let's go start with this part here. So they want to know where is, now what is this, guys? That is your first derivative. What is the first derivative of a graph? Tell us again. Gradient. So they want to know where is the gradient of that graph f positive. Remember, positive gradients look like that. Negative gradients look like that. So where is the gradient positive? So we're going to go find out where that graph has a positive gradient. It would be literally all of that up to there. And then you can see there is where it would begin to turn, and you can see that the gradient is then becoming negative. Okay, so that area there is where it has a positive gradient. Now, in that same area that we've just looked at, are there any places where the graph of f, again, is positive? Remember, when a graph is positive, it means above the x-axis. So on that yellow graph, where is it also above the x-axis? Well, that would be here. And then actually all of that. But the overlap, where's the overlap part? The overlap part is going to be all of that. Can you see that's where we've got an overlap? And so that is where the answer will be. It's going to be from this x value, which is negative 30, up to this x value where the gradient stops, which is actually there, which is at 60. So it's going to be from negative 30 up to 60. So let's just write a quick little answer now. We'll go write out the formal answer just now, but it's just from minus 30 up to 60. Now we need to go look at scenario 2. So we can ignore this one now. Now we're going to go look at scenario number 2. So in scenario 2, we start off by looking at, are there any places where the gradient is negative for the graph of f? So where is the gradient, where's the gradient negative? Well, that is literally just this portion here. That's where its gradient is negative. You can see that, right? Now, in that area there, in that same area, are there any places where the graph is below the x-axis? Because that's what negative means, below the x-axis. Well, no, not in that area there. I can see it is below the x-axis here, but that's not in the same area there. So there's no overlap. So this part here doesn't give us any other solution. And so then our only solution is this. Now, obviously, we can't write it like that. So you can either write it as minus 30 up to 60 like that. Or if you prefer set builder notation, you can go from minus 30 up to 60. In the diagram below, DC is a vertical corner post. Okay, so that line there is completely vertical. And then this is a horizontal plane. Okay, so you got to try learn to think, or you got to become comfortable with thinking in 3 dimensions. So kind of like this, guys. You see what we've got here? I've gone and remade this for you. So you've got the floor. This part here is on the horizontal. So that's your floor. So it's flat on the ground. And then you've got this that is at 90 degrees. So this is like almost like you can think of a netball pole going directly up, and then all of this is on the netball court itself, on the flat court itself. Okay, so this part is flat on the ground, and then this part is like a netball pole, and then this part here could be like a piece of rope that is connecting up to the top over there or something like that. Okay, and then they tell us that DC is a vertical corner post. The angle of elevation is theta. And then they tell us that that angle is that angle is that. And the length of DC is h. Okay, so everything has been shown on the diagram. First question for 2 marks. Let's just get rid of all of that over there. Okay, determine the length of CB in terms of h and theta. So h and theta are in this triangle. So we will work in this triangle over here. Okay, now grade 11s and 12s always think that because we're in grade 11 and 12, we have to use those a over sin a formulas, or they think we have to use the c squared, a squared, b squared minus 2ab cos c formulas. No, if it's a 90-degree triangle, you don't have to. Then you just go back to SOHCAHTOA. Okay, so don't forget about those. And so what we have, the angle that we have is here. The side that we already have, which is h, is the opposite. And they want us to calculate CB, which is this one down here at the bottom. So that is the adjacent. So opposite and adjacent is tan. So we will say that the tan of that angle is equal to the opposite, which is h, over the adjacent, which is CB. Okay? Now you just have to get CB alone. So what you can do is you can think of this as tan theta over 1. Cross multiplication, so that's going to give you CB multiplied by tan theta equals to h. To then get CB alone, you're just going to say h over tan theta. And so there's the answer, h over tan theta. Okay, now this one says, prove that AB is this. Now don't even look at that, just go find AB. Okay, I don't look at that at all. I just go look at AB, I go find AB. That's what the question is actually telling us to do. So here we have this length over here now. We know what that length is. It's h over tan theta. So don't treat that as an unknown anymore. We have it. So we have this length, and they're trying to get us to find this length. And then we've got this angle and this angle. So this looks like a good setup for a sin rule. So we know that that's a over sin A equals to b over sin B. And it's not a 90-degree triangle, so we're not going to use SOHCAHTOA. So we know that this formula is all about the opposites. So this side is opposite that angle there. So we need to know what this angle is. We need to go calculate that angle. And then the other side we have is this one here. Remember, we've got that as this. And the angle opposite that one is that. Okay, so we got those. That's fine. So we've got this and this. So we find there. And now we want to use this side and this angle. So we need to find this angle first. So how are we going to find that angle? Well, we know that this is a triangle. Okay, and we've got this angle and we've got this angle, so we need to go and find that angle. So how, sum of angles in a triangle. So we can just go say that angle ACB, which is going to be this one over here, that is going to be equal to 180 minus alpha minus beta, and that is just because of some angles in triangle. And so that's the answer. We've now got that. We've now got this angle as 180 minus alpha minus beta. So now we can go use this formula. So we can say that A, which is going to be AB, over the sin of its angle, so the sin of the angle opposite AB, which is this one over here now. So we'll say sin of 180 minus alpha minus beta. Notice I'm not looking at this. I don't care about that right now. And then I'm going equals to the other side that we have, which is BC, over the sin of its angle. So the angle opposite BC is alpha. And there we have it. Now, we just need to play around with this a little bit. So I know that BC is equal to that, but I'm not going to fill that in right now because I don't feel like having to write everything over the whole time. So the thing I want you to have a look at is this area here. You know how on cast diagrams, we know exactly what to do if we have 180 minus x. But this isn't 180 minus x. This is 180 minus something. So what we do is we need to modify this a little bit. So the way you do it is you take out a negative as a common factor from these two. So then what you're left with is alpha plus beta, like that. So now all of a sudden we have a scenario where we have 180 minus something. Just like over here, 180 minus something. So here it's x, whereas here it's this alpha plus beta. So we know that the sin of 180 minus x normally just becomes sin x. So then what is this going to become? Well, that is now going to become the sin of that. Okay? So I'm going to replace this now with sin of that stuff. There we go. And I'm now going to start rearranging this equation to get AB by itself. So I'm going to... So if we rearrange this now to get AB by itself, you're going to end up getting BC multiplied by sin alpha plus beta over sin alpha. Okay, so all I did was I just multiplied that up there. It's like doing cross multiplication, but I didn't take this one to the left because I don't want it on the left. Okay, so now we have this. The next thing we do, I still don't care about that. The next thing I want to replace the BC with what it is over here. CB, BC, same thing. And so we're going to replace that with h over tan theta. Okay, so AB is now going to be equal to h over tan theta multiplied by sin of alpha plus beta over sin alpha. And then this part here actually just ends up popping down to the bottom here. And so we end up just having it like that. And now we have exactly what they wanted anyways. So the question actually just says go find AB. And then you might just have to move things around just to make it look exactly like that. But there we go. Now this one for 2 marks, these are usually pretty easy. Calculate the value of AB if H is 31.2. So they're giving us H, they're giving us alpha, they're giving us beta, and they're giving us theta. Stupid question, because now we just have to go fill it in. So you're just going to go fill in 31.2. Sin of alpha, which is 52.2, plus beta, which is 23.5, and then at the bottom we've got tan theta, so tan of 42.3, and then sin of alpha, which is 52.2. Okay, doesn't get easier than that. And then you're just going to go fill that all in. And so we should get 42.05. And then just check, did they give us any units? Oh yeah, there is meters over there, so we'll just say meters. O is the center of the circle. LM produced and PO produced meet at N. MN is equal to OL. Okay, so that's important. MN has the same length as OL. Okay, so those two have the same length. And LNO is 19 degrees. So LNO, okay, so they've showed it to us over there. So that little angle is 19 degrees. Fantastic. 5 marks. Calculate the size of LOP. LOP. So that is this angle over here. That is the unknown for this whole question. Did you guys know that I'm actually from a like a very traditional Afrikaans family where we lived in the Karoo, and my nickname is actually Loppies. So they sometimes just call me LOP. So yeah, quite interesting. I remember often, like back in the day when I was milking the cow out in the fields, my mom would come out the house and she'd be like, Lopus, and then I would be like, yes, and then she'd be like, come, and then I'd go for dinner, and Yeah, so that's me, guys. So from now on, if you want to call me Lopis, that's fine. I mean, that used to be my name back in the AM. Okay, so calculate with reasons the size of LOP. So that's the angle we need to find. Okay. Okay, well, it's really not the most difficult question because there's a whole bunch of lines here that are going to be equal in length. So if we know that, this is a radius of a circle, that one there's a radius. So that means that this one's also going to be, OM is going to have the same length. So we can say that OM is going to have the same length as OL because they are both radii, right? Can you see that? That length and that length must be the same. So now we can see that in this triangle, we've got these two sides are the same. So let's just look at that again. In this triangle, we now know that those two are exactly the same. And so that is an isosceles triangle. And so this angle here, this little corner angle, is going to be exactly the same as that little corner angle just because it's isosceles triangle. So we can say that angle O1 is going to be equal to angle LNO, which is 19 degrees. And the reason for that is because those are the angles that are opposite equal sides. Okay, so we now know that this is 19 degrees. Okay. Now, there's different ways of handling this next part. If you are comfortable, well, what a lot of learners do is in this triangle here, whoa, what the heck happened there? In this triangle here, you could go work out this angle now, and then you could work out this angle because of angles on a straight line. But if you understand exterior angle of triangles, then you can easily go straight to this one without having to do that step that I just explained. But if you don't, or if you're not comfortable with exterior angles, then you can just do it the longer way. But what you should know, if you do know exterior angles, is that M2 is going to be, you see that in this triangle here, M2 is what we call the exterior angle. And the exterior angle is always the sum of the two opposite interior angles. And so M2 is just going to be 19 plus 19, which is 38. And that's just going to be because it is the exterior angle of the triangle. Like I said, if you're not comfortable with exterior angles, I wasn't when I was in grade 12. I used to do the longer method. Sum of angles in a triangle, angles on a straight line. You should get to the same M2 value of 38. Okay? Now, if you now look inside this triangle, it's also isosceles. And so this angle is going to be the same as this one. So that angle L is going to be MLO. MLO is going to be equal to angle M2. And that's also because of the fact that we've got angles opposite equal sides. Angles opposite equal sides. So then we can say that angle MLO is also going to be 38. So now we have 38 over here. Okay, now I want you to look completely in the big triangle, which is this one here. And what you should identify is that, you could use angles on a straight line again if you need to. So you could, if you wanted to, we know that this is 38. So you could go work out this angle here. And we already have this angle here. So you could use angles on a straight line over here to find O3. Perfectly fine. But what I'm going to do is I'm going to realize that this angle here, O3, is the exterior angle of that yellow triangle. So the exterior angle of a triangle is always the sum of the two opposite inside angles added together. So I'm then going to say that angle LOP is going to then be equal to 38 degrees plus the 19 degrees. And that is because of exterior angle of a triangle. And so angle LOP is going to be equal to 57 degrees. Complete the following statement so that it is true. The exterior angle of a cyclic quad. Okay, so if we have a cyclic quad, so something like that maybe, and we've got this exterior angle over here, then what we've learned, that is, if that is, for example, let's say 94 degrees, then the opposite inside angle will also be 94 degrees. So the exterior angle of a cyclic quad is equal to the interior opposite angle. In the diagram below, O is the center of the circle, AC is a tangent, D and E are points, Prove the theorem that states that the angle EBC, okay, so that one there is equal to that one. So this is the tan chord theorem. Okay, so there's different ways of doing the tan chord theorem. I've seen other ways that some textbooks use where they do like a setup like this, and then it goes to there, sorry. So if you want to use that method, you can. It's not the method I really use. I use this method here. So what I do is I construct this line going straight down to there. So I construct OB and OE. So construct OB and OE. Whoops. Okay. Now this angle here is 90 degrees. So angle OBC is 90 degrees, and that's because you've got a tangent perpendicular to a radius. And because remember, we know that a tangent and a radius always makes 90 degrees, okay? Then what we do is we let B1 equal x. So this over here is x. Then what would this little angle be? Well, that little angle would then be 90 minus x. So angle OBE would be equal to 90 minus x. Okay, so we now have this as 90 minus x. Now, can you see that these two are the same because they are radii? So we can just say that they are the same. So OB is equal to OE because they are radii. So that then means that this angle and this angle must be the same. So angle OEB, which is this one, must then be 90 minus x as well because they are the angles opposite equal sides. Okay, so we now have this as 90 minus x. Then what we do is we go use sum of angles in a triangle to find this angle here. So we can say then that angle BOE, which is this one, is going to be equal to 180 minus 90 minus x. Or we should put that in brackets. Minus 90 minus x, and that is just because of some angles of a triangle. And so if you had to go work out BOE, you should end up with 2x eventually. So this is 2x. Okay. Now, oh no, I wanted those. My bad. So what we now do is we can just use angle at circumference equals 2 times angle at center. So here we can see that this is 2x. So then if you had to go to this angle here, you would end up with x over here. So we can say angle D is going to be equal to x because of angle at circumference equals to 2 times angle at center, like that. And so this is x. And so there we've just shown that this angle and this angle must be the same. And so therefore EBC must be the same as angle D. In the diagram below, FGH is a tangent to the circle with center O, BOG is a diameter, AB is parallel to EG, and G1 is equal to 59, and then CD is equal to DE. Okay, so everything they've said has already been shown on the diagram. So the first question, determine with reasons the size of angle CDO. So C, where's C? Then go to D, then go to O. Okay, so guys, remember the first circle theorem that we learn about in grade 11 is that if you have a center of a circle and you have a line, if you then connect to that line in such a way that these two are the same length, then that is automatically 90 degrees. You see how we've got a center over here, then we connected to that line such that these two are the same, so that angle must be 90. So we will say that it's 90 degrees. And what is the reason? Because learners get this confused. What was the reason that you said that these are 90? It's because these are equal. So it's because we already have the midpoint. So it's because we have the line from center to the midpoint of a chord. Okay, some learners think, oh, it's because we have a line from center perpendicular to chord. No, we didn't know it was perpendicular at first, right? We knew that it was the midpoint, so that was the reason we said what we said. Okay. Now this question says, what is B1? B1, oh, let's first just remind ourselves that that's 90. B1, okay. So, right, can you see we've got a tangent here? And then we've got a chord over here. Whoopsie. Now that chord and tangent, they've got this angle 59 in between. So if we then take the edges of this chord and this chord here, and we see where they come together at B1. So we can use the tan chord theorem and say that this angle and this angle must be the same because of the tan chord theorem. So we can just say 59 and we can just say tan chord theorem. Okay, so moving on now, let's go to, so this is now done, this is now done. So this one here, G2, okay, so G2 is over here. Right, so guys, that's a straightforward one. Wait, why is that worth 4 marks? That's crazy. Check this out, guys. We've got a tangent. Sometimes they do make this mistake in an exam. And we've got a diameter or a radius, whatever you want to think of it as. We know that the angle that they make is 90 degrees, right? So let's start there. We can say that angle OGF, okay, that's maybe why it's 4 marks, because we first have to say this. OGF is 90 degrees, and that's because we have a tan perpendicular to a radius. Okay, so that's 90. So then we can then just say that therefore G2 would then just be 90 minus 59, which is 31 degrees. So I went and looked on the memo. They did a much longer method, but then they had a second method where they just did this, and it was literally just like a one-liner for 4 marks. So I don't think the examiner or the person who set up the question realized that there was actually such an easy way to do that. But you would get your 4 marks, okay? Now this one here says, so let's just fill in what we have. So we've got this is 31. We've filled in that is 90, and we got B1 is 59. And okay, come on, where's the catch? This has been too easy. I'm getting nervous. So they want the size of G3. So G3 is over here. Okay, so that's actually just the parallel lines. Can you see here? Boom, 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 alternating angles. So that's going to be 59 degrees. So 59, and we can just say alt angles, Y, because the line AB is parallel to the line EG. Okay, and then this one for, well, let's just fill in that we have that. So that is 59. 59, so that's also 90. Okay, that's interesting. So that's clearly a diameter then. Okay, interesting. Right, this one over here says C1, angle C1. So C1 is up here. Okay. So the first thing I kind of see is like a bow tie kind of thing developing. So I just want to see what produces C1. Well, if I go back and I go back, okay, so the chord that is making C1 is this one. So does that, you see what I mean? I went to the angle C1 and then I just extend the lines backwards there and there. So that means that it's this chord here that is making C1. So then I just look, where else is that chord? What else is that chord making? Well, if I go this way, boom, and I go this way, boom. So I know that that chord is also making that. So when the chord is making those angles, then those angles are all the same. It's angles in the same segment. If I had to go and erase all of these lines and just leave this shape here, whoops, come on. You would see the bow tie there. So these two angles have to be the same because they are both coming from this chord over here. Okay, so that's a little trick to do, guys. You look at the angle, you then go back and you see where does it start. Boom. So then you connect these two lines over here, or these 2 points, and that gives you the chord that makes that angle. So you connect them. Okay, now you take that chord and you see where else do those 2 points come together. So you can go this way and that way. Okay, so this was 59, and then we've just seen that this would be 31. So we can say 31 angles in same segment. Okay, now this one for 3 marks. Prove that AC is parallel to OD. So AC is parallel to OD. Okay, so prove that those 2 angles are equal. Prove that those 2 lines are parallel. Right, so if you look here, if you look at this shape here, that is a cyclic quad because it's touching the circle in 4 different places. 1, 2, 3, 4. So that's a cyclic quad. Now we know that the opposite angles of a cyclic quad add up to 180. So this whole angle and this whole angle must add up to 180. So we can say that angle BCD, which is this whole angle here, okay, that when you add that together with angle G3, which is down here, it should add up to 180. And that's because of the opposite angles of a cyclic quad. So we can then go and say that angle BCD is going to be 180 minus 59, and that's going to be 121 degrees. So that's this whole angle. So C1 and 2 is 121, but C1 is already 31 degrees. So then we can say that C2 is going to be 121 minus 31, which is 90 degrees. Okay, so now what we've just found is that this angle is 90. So that means that these 2 lines have to be parallel, because we've just seen that we know this is 90 and we know that this is 90. So we've got a co-interior angle over there. And when the co-interior angles add up to 180, they parallel. They don't have to be equal necessarily, but they must add up to 180. So then what we can do is just show that if you take angle C2 now and you add it with angle ODC, we end up with 180, okay? Because it's this one which is 90 and this one which is 90. So therefore, those 2 lines must be parallel. So AO must be parallel to DO, and that is because the co-interior angles are supplementary. Supplementary means that they add up to 180. In the diagram below, P, A, E, R, and S are points in the circumference of the circle with center O. DSB is a tangent. AOWS and RP. AOWS and RWP are straight lines. AOWS. Okay. And then they tell it. Okay, so everything that they've mentioned is already on the diagram. 4 marks, 5 marks, and 6 marks. Craziness. Prove with reasons the following. Prove that PW is the same as WR. Okay, so PW, PW, okay, is the same as WR. Okay. Right, so immediately what I see forming here, what I think it's going to be is, you know, in the beginning of grade 11, one of the first circle theorems we learn is, sorry, I'm just trying to draw a good circle here, is that when you have a circle center and you have a line, and if you can, if you know that this is 90 degrees, then we can say that these 2 are the same. So I think that's what's happening here. You see, if you go from the center to there, if we can somehow show that that's 90 degrees, then it means these 2 lines have to be the same length. I think that's what it's going to be. It might be something totally different. Okay. Okay, so if we look at these 2 lines, we know that they are parallel. So we know that with parallel lines, you've got alternating, corresponding, and co-interior. So here we've got a co-interior kind of scenario. Now, we must remember that if you have a radius and you have a tangent, then they will always make a 90-degree angle. right? If you have a circle and you have a radius and you have a tangent, then that angle is always 90 degrees. So we can then say that this angle here, which I'll call it BSO, is going to be 90 degrees because we have a tangent that is perpendicular to a radius. Okay, so this is 90. Now, because these lines are parallel, the co-interior angles, they must add up to 180. So we can then say that angle BSO plus angle W4 will be equal to 180 because they are co-interior angles, because the line, what did they call it? PR, parallel to BS. So if we then say 90 plus angle W4 is equal to 180, then angle W4 must be 90 degrees. So because we now know that this is 90 degrees, then we can go back to that original theorem that I told you guys, that if you have a circle and you have a line from the center hitting a chord at 90 degrees, then these two have to be equal. So we can then end off by saying, therefore, PW would have to be the same as WR. And this is because we have a line from the center, and that line is perpendicular to the chord. Okay, so yep, those two lines are equal in length. Just remember that. I think that's going to come up later on. It's going to come up somewhere here. I think we're going to have to replace one of these with the other or something like that. This question. Here we have to prove that this triangle. So let's go find triangle APS. Okay, so that triangle there, they want us to prove that that is similar to RWS. Okay. So immediately, can you see the bow ties there and there? Can you see that? If I had to even take away all these circles, all these triangles, and just go like this, can you see that? Boom. Okay, so let's go back. Okay, now the next thing is, remember earlier in this first question, we showed that this was 90 degrees. So that means that this one is also 90 degrees, right? So let's just quickly go say that W1 plus W4 must add up to 180, and that's just because of angles on straight line. And so W1, it looks like a weird E, W1 is going to be 90 degrees. Okay, so we know that this is 90. Now in the green triangle, this would also be 90. Why? Because it is the angle that is being produced by a diameter. Remember that when you have a circle and you have a diameter, then the angles that it makes on the circumference are always 90 degrees. Angle in a semicircle, remember? So we can say that angle SPA equals to 90 degrees because of angle in semicircle. So therefore we can say then that W1 is the same as angle SPA. So now what we've done so far in these triangles is we have shown that these two angles are the same, and then these two are the same. So then remember, that automatically then allows us to say that the third angle pair must be equal. So we can then say that S3 must be the same as S2. And that's just because they're the remaining angles that we haven't found yet. And that we always say as some angles in a triangle. Okay, so we've now gotten all of that. So then we can say, therefore, these two triangles must be similar because of angle, angle, angle. Done. Okay, so we've done 2.1, done to 10 we've done 10.1 and 10.2. Lastly, 10.3. Go and prove that. Okay, so what I always would say is that this question here, very often it's going to need information from the previous questions. So don't try find anything on the diagram just yet. Go do as much as you can with this. So we know that when you've got this, we can go make our ratios. We can say AP over RW is the same as PS over WS, which is the same as AS over RS. And you could say here corresponding sides in proportion, but what I do most of the times nowadays is I just say similar triangles. Okay? So what I then would do is I would go see if I can find as much as this. So there's a WS and there's a AS. And then RS is here. Fantastic. So I'm definitely going to take these two and I'm going to do cross multiplication. So we can end up with PS multiplied by RS equals to AS multiplied by WS. So there we've already got the WS and AS part. WS and AS part. And we've got one of the RS's over there already. But it would be fantastic if this was also an RS. So then I would look at here and I would see, you know, if life was super easy, they would have said something here like PS equals to RS. And then we could have just changed this PS into RS and then we would have been done. But that ain't going to give us 6 marks. For 6 marks, there's definitely something extra. Okay, so I'm now going to assume that we've now used everything that we need from here. And so just to recap, remember, we are almost at the final answer. It's just this that's getting in the way. That's the only thing that is in the way. Now we know, so let's go look at PS. Where is PS? Okay, so PS is here. Okay, right. And we would love for PS to be the same as RS, because then I can replace this with RS, and then this will be RS squared, and then we're done. So here's RS. So I think the next goal that we have, guys, is to go show, or to try prove that these two angles are the same. Okay? So what we've already done so far in this earlier questions is we proved that those are the same. And now we somehow need to get this one as well. Okay, I've done it. That was actually a really easy question. So if you look here, we know that if you look at this line here and you look at this tangent and you look at the angle between here, you could use tan chord theorem. Now if you use tan chord theorem with this chord, you could go there, you could go there, okay, which just tells us that this angle and this angle is the same. But you could also just go straight up to there, okay? So I'm going to go straight to that. So we can show then that angle S1 is equal to angle A, and that's because of the tan chord theorem. So now we've got that. And then we know that these lines are parallel, and so angle S1 is the same as angle P3, and that's because of alternating angles. Why? Because PR is parallel to BD or BS. Okay, so we can then now say that these two angles are the same. So therefore angle P3 is the same as angle R2. And so let's just write out what we had here. PS times RS. So then we can say therefore, so because we are now in this triangle and we've just proved that those two angles are the same, then those two lengths, PS and SR, must be the same. So we can say that PS must be the same as RS. Why? Because those are the sides that are opposite equal angles. Okay, it's like isosceles triangle vibes. And so we can then go replace this with RS And so therefore we can say RS squared equals to AS times WS. Done.